Volcanic activity beneath Yellowstone's massive caldera could be on the move. As we know, Yellowstone is one of the Earth's 22 some-odd supervolcanoes. Volcanic activity bubbling away beneath the Yellowstone National Park in the U.S. appears to be on the move. And new research shows that the reservoirs of magma that fuel the supervolcano's wild outbursts seem to be shifting to the northeast of the Yellowstone caldera. This region could be the new locus of future volcanic activity, according to a team led by seismologist Ninfa Bennington of the U.S. Geological Survey. On the basis of the volume of rhyolitic melt storage beneath northeast Yellowstone caldera and the region's direct connection to a lower crustal heat source, we suggest that the locus of future rhyolitic volcanism has shifted to northeast Yellowstone caldera, the paper writes. In contrast, post-calderic rhyolitic volcanism in the previous 160,000 years has occurred across the majority of Yellowstone caldera, with the exclusion of this northeast region. Yellowstone is one of the world's largest supervolcanoes, a vast, complex, dynamic region of Earth's crust that is both spectacularly beautiful and deeply dangerous. In the past 2 million years, Yellowstone has undergone 3 huge supervolcanic caldera-forming eruptions, those that create the cauldron-like basins on Earth's surface when a subterranean magma chamber empties and collapses in on itself on the hollowed-out cavity. And these huge eruptions have been interspersed with smaller eruptions as well. The caldera-forming eruptions at Yellowstone are sourced from reservoirs of rhyolitic melt, that's silica-rich magma, the volcanic equivalent of granite, sticky and viscous and slow-moving, and thought to be stored in vast volumes underneath the Yellowstone region. Previous studies presumed the rhyolitic reservoirs were supported by deeper reservoirs of basaltic magma, molten material that has a much smaller silica content than rhyolite, but abundant iron and magnesium. It's also significantly less viscous than rhyolite, but also denser, and the way it conducts electricity differs to rhyolite. This latter difference in properties gave Bennington and her colleagues the tools they needed to probe the magmatic reservoir contents beneath the Yellowstone Plateau. One way to monitor activity beneath Earth's surface involves measuring surface variations in the planet's magnetic and electric fields. This is known as magnetotellurics and is particularly sensitive to the presence of subsurface melts. Bennington and her colleagues carried out a wide-scale magnetotelluric survey across the Yellowstone caldera and used the resulting data to model the distribution of the melt reservoirs lurking therein. The results revealed that there are at least 7 distinct regions of high magma content, some of which are feeding into others, at depths between 4 and 47 kilometers, that's 2.5 to 30 miles beneath the ground, down to the boundary of the crust and the mantle. The most interesting melt storage was in the northeast, and there huge reservoirs of basaltic magma in the lower crust heat and maintain chambers of rhyolitic magma in the upper crust. These chambers of rhyolitic magma contain an estimated melt storage volume of around 388 to 489 cubic kilometers, almost an order of magnitude higher than melt storage zones to the southwest and north where previous eruptions took place. This volume, the researchers say, is also comparable to the melt volume of previous caldera-forming eruptions in Yellowstone, that is, super eruptions. The rhyolitic caldera-forming eruptions, the researchers note, were interspersed with smaller basaltic eruptions within the caldera. However, it's unclear exactly how these kinds of eruptions work. The team's research suggests that the rhyolitic magma chambers have to cool completely before the basaltic magma can move in. Now, exactly when and how these future eruptions are going to take place will, the researchers say, require further analysis, and their research has been published in Nature magazine. This is by Michelle Starr and Science Alert. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.